Hello everyone! In this video, we'll be introducing the transport layer multiplexing and demultiplexing, as well as how they work. Multiplexing and demultiplexing are used in almost all transport layer protocols, the TCP and the UDP. The two layers associated are the transport layer and the network layer, in which logical communication is provided through the layer's performances.
The topics that we will be going through are the definition of multiplexing and demultiplexing, requirement and format for multiplexing, as well as connectionless and connection-oriented multiplexing and demultiplexing. Multiplexing. The transport layer handles data from many sockets and adds a transport header to each segment, then sending it to the network layers to be sent to a receiving host. Demultiplexing. Use the header info to deliver received segments to the correct socket and receiver side. Socket. Add transport header to each segment, then send to network layer to be sent to receiving host.
Transport layer multiplexing requires 1. Sockets that have unique identifiers, and 2nd, each segment to have source port number field and the destination port number field. And below is the TCP/UDP segment format. Connectionless multiplexing and demultiplexing. UDP with two tuples. When UDP socket is created, the transport layer automatically assigns a port number to the socket. An example of this would be for host A with the UDP port 19157 to send a chunk of application data to a process with the UDP port 46428 in host B. The transport layer in host A then creates a transport layer segment that includes application data with the source port number 19157 and the destination port number 46428. The transport layer then passes the resulting segment to the network layer. The network layer encapsulates segment into an IP datagram, then make a best effort attempt to deliver the segment to the receiving host. If the segment arrives at the receiving host, the transport layer of the receiving host will examine the destination port number in the segment. In this case, the port number is 46428. And will deliver the segment to its socket, which has the same number. Now, moving on to the connection-oriented multiplexing and demultiplexing, which uses the TCP connection and uses 4 tuples. The socket is identified by 4 tuples. The first one is the source IP address, the second one is the source port number, the third one is the destination IP address, and the fourth one is the port number destination. So when the TCP segment arrives to the host uses all 4 values to direct or demultiplex the segment to the appropriate socket. In conclusion, without multiplexing, the demultiplexing on the receiver side would not know which socket to direct the segment to. And this process happens ideally in the transport layer. So it's finally the end of the video. Thank you for watching and we hope that you found this video helpful.